Okay. Next thing we want to talk about with probability is odds, how it relates to probability, but also like how it's different. Has a slightly different definition, right? And it's connected to probability. It's just another way to express it, right? So remember, the probability of an event is the number of ways an event can occur over the total number of possible outcomes. So if you roll a single-sided die, the probability of getting a 1, well, there's only one way the event can occur out of 6 possible outcomes. So it's 1 over 6, or 1 to 6, or 16.7%, or 0.167. You can express it ways. Okay? Odds, we talk about a couple of things. The odds in favor of some event occurring, and the odds against an event occurring. So the odds in favor of an event, is the number of ways the event can occur. The number of ways an event can occur over, and we don't, like, you can show it as a fraction, but it's really a ratio. We don't normally use decimal and percent for odds. Over the number of ways it can. Over the number of ways it cannot. And the odds against an event is just the flip of that. So this would be the number of ways an event cannot occur. Cannot occur over the number of ways it can. Okay, so let's look at some examples, because that's the best way to reinforce this. So you're going to randomly choose a letter from the alphabet. What's the probability of choosing a vowel and include Y as a vowel?
6 out of 26.
6 out of 26. Or you could reduce it if you wanted to, as if you didn't have to. You could write it as a ratio, 6 to 26. Okay? And like I said, with odds, you could write as fractions and ratios. So, think about the definitions now. What's the odds in favor of choosing a vowel? Well, how many ways can a vowel be chosen? How many ways? 6. How many ways can't it be?
20.
20. It's got to be the remainder of the 26 letters. Or 6 to 20. Or even if you wanted to reduce it, 3 to 10. But you don't necessarily have to. See the difference between probability and odds. We don't use the same numbers. What would the odds against choosing a vowel be? 20 over 6. you just flip it. Or 20 to 6. Or 10 to 3. Okay. Next example, you roll a 6-sided number cube or a die. What's the probability of rolling a number less than 3?
3 and 6.
Or 6. And I like the way you said that, out of 6. Or you could go to decimal or percent. But now odds. The odds in favor of rolling a number less than 3. Well, there's 2 ways it can happen. 2, how many ways can't it happen? 4. Because there's 6 total ways it can happen. Or 2 to 4. Or 1 to 3. A lot of times we do reduce odds. Like when you see odds in sports betting, it will usually be in lowest terms. Okay. So like if you think there's something like a different, like again relating to sports, you know, like the Jets have a 1 to 3, or sorry, the Jets odds of winning tonight are 3 to 1. That means if they played 4 games, the Jets would be expected to win 3 and lose 1. Anyway, going back to this. What's the odds against rolling a number less than 3? 4 to 2. Oh, sorry, this is 1 to 2, not 1 to 3. So here you can just listed the differences between probability and odds. So remember yesterday we talked about the probability of an event occurring if it's in fraction form or decimal form must be from 0 up to and including 1. It can never be greater than 1. Odds can be, okay, but they can't be negative. The sum of the probability of an event occurring and not occurring is always 1. Okay? But with odds, the odds in favor and odds against are always reverse ratios. So if we're given odds, how can we figure out probability? The odds in favor of picking a green marble out of a bag, multicolored marbles, are 5 to 1. What are the odds against? 1 to 5. Okay. What's the probability of picking a green marble? Okay. Well, we got to look at this. The odds in favor are 5 to 1. So we've got to translate this to probability. You figure it out? How many ways can we pick a green marble here? 5. Out of how many ways total? 6. Because there's 5 ways to pick a green, 1 way not to. So that means the probability will be 5 out of the total in the odds. So 5 out of 6. Okay? Because odds of green over odds of green and not green. That's how we get the 6. So, because it doesn't make sense to say the probability would be 5 out of 1. The odds in favor of the Blue Bombers winning the next game are 2 to 3. What's the probability of them winning? 2 to 5. So it'll be 2 over 2 plus 3, which is 2 bits. 4, 2 to 5, 4, 0.4, 4, 40%. All of those are correct. And I just added B. How do you make this into a percent? Well, 2 divided 5 is 0.4. Move the decimal twice, 40%. Find the odds against the Bombers winning. Now we're back to odds, not probability. Really good. Okay. Last example. So probability, and I believe odds as well, when you're given a data set. Right? And the data set is below. This is just a picture of all the possibilities in standard deck of cards. 13 spades, 13 clubs, 13 diamonds, 13 hearts, 26 black cards, 26 red cards, 4 of each, aces, 2s, 3s, all sorts of different ones. Okay. So we would be able to calculate probability and odds from that. But what happens if you actually do it, if you try it? You're not going to get the same odds. And if you guys remember this, the two of you from stats last year, probability is unpredictable in the short run, but predictable in the long run. So like, let's say you flip a coin 10 times. Probability dictates that I should get heads. How many? 5 of them, right? That's what probability says. But if I actually try to flip 10, am I guaranteed to get 5? No, I might get 6, I might get 3, okay? But if I did it more times, like if I did it 1,000,000 times, okay? You would expect 500,000 heads. I probably still wouldn't get that, but I'd be really close. Okay, it'd be really close to 50%. If I did it 100 million times, it'd even be closer. Okay, so that's sort of the difference between theoretical probability and experimental probability when you actually do it. So these two did an experiment to find the probability of drawing certain cards from standard deck of 52, and they did it 200 times. So when they randomly drew 200 cards, they got read 107 times. Well, theoretical probability tells us they should have got 100, but doesn't necessarily mean they're going to get exactly 100. Queens should have happened, what, 1/13 of the time. 4 over 52 or 1/13. Not quite when they actually did it, and then so on. Okay? So based on this, not theoretical probability, what's the probability of drawing a red card? Right, and then just make that into a percent. Yeah, multiply was it? 54, rounded?
Yes.
Okay. What's the probability of drawing a queen? Express that one as decimal. So 20 out of 200, divide by 2, and you get exactly 0.1. So these, we're just basically using the table and just remembering that we should 200 draws. So it's pretty straightforward. The probability of drawing a red jack as a ratio. 6:200. You could reduce that, you don't have to. Okay, like I said, odds we normally reduce. Now, this is where it gets a little different, odds. Because now we're no longer using the 200. We're using the odds in favor of what event we're asked, and then the odds against. So what are the odds in favor of drawing a face card? How many ways can I draw? How many ways was it not drawn? 200 minus 45, right? So it would be 45 to 155. You could reduce that, you don't have to. The odds in favor of drawing a king of spades. That would be 5 to 195. And the odds against drawing a black odd. Well, this time the 47 goes on the bottom. No. Yes, it does, sorry. So it'd be 200 minus 47. Minus 47. And that works out to 153 to 47. So that's the relationship between odds and probability and how we calculate each of those. Okay. Okay.